So, good afternoon, everyone. Welcome to this week's NITheCS Micro-school. My name is Dean Brand. I'm a second-year PhD student at Stellenbosch University, working under the supervision of Francesco Petriccione, who's the director of NITheCS. Today's micro-school is based on the topic of data velocity, polars meets GPU power. And the speaker is Pashlene Naidoo, who is a first-year master's student in the quantum research group at Stellenbosch University, working under the supervision of Dr Yaseera Ismail. Her current research focuses on the investigation of high-dimensional encoding for quantum communication. And she completed her bachelor's and honors at the University of KwaZulu-Natal, majoring in applied physics, and has given a micro-school before on Pandas, which is a similar data science package. So is the best person to be giving us this talk today. And if there are any questions or comments about suggested micro-school topics, please feel free to leave them in the chat. And with that, I'd like to hand over to you, Pashlene, to take it away.
Hi everyone. So today I will be presenting an introduction on the polars library. We will first go through the differences between pandas and polars and then proceed to use the Nvidia's T4 GPU engine that's on Google Colab, and can use that with the polars library. So this tutorial was inspired using the polars documentation. So this is the polars website, and this is a new library that was recently released. It was first created in 2020, but it was officially released so that we could use it for data analysis in July or June this year. And it's getting quite popular already. You can see that it has about 75 million downloads to date. And it is what is known to be the fastest data processing library at the moment. And we can see here that polars claims to say that it is the fastest compared to Pandas and PySpark and Dask. And then we are going to see if this is true. There is the API reference to Python, and we can see that there's many tutorials on how to use the functions in polars. So let's get started by installing the packages for polars and pandas using the pip install command. And today we're going to be using the hvplot library, which is a high-level plotting interface built on HoloViews. This is a beautiful and interactive way to plot your data, and we're going to see this at the end of the tutorial. So we're going to import the library. So we're going to import time. We're going to see how this is going to be used. And once you've done that, we can see how the differences between pandas and polars. So the main difference is that the data frames in pandas, it has indices on its rows, and with polars it doesn't have indices, but rather it has the data type on its column. So the developers in polars, they said that they didn't find a need for the indices on the data frame. They said that it's much faster to process the data without the indices. So moving on, another difference is the memory format. So polars use the Apache Arrow format, which is optimized for in-memory and storage and enhancing speed and memory efficiency, whereas pandas, it represents data in memory with NumPy arrays. So to see this, if we create some sample data and we create the data frames in pandas and polars, we can see the data types. We see here by the pandas representation, it's NumPy based, and the polars representation is the Apache Arrow. It's compatible with Arrow. And moving on, we can look at the parallel operations. So Pandas is a multi-threaded library, and this exploits the strong support for concurrency in Rust, and to run many operations in parallel. While some operations in Pandas are multi-threaded, the core of the library is single-threaded, and to perform parallel operations in Pandas, you need to use an additional library such as Dusk. To see the difference between the execution times with Pandas and Polars, we create a large data set of 10 million integers. So we put this in the Pandas data frame, and then we do a simple operation such as squaring each element. And then we're going to use the time function just to see how long Pandas takes to execute this computation. So when we run this code, we see that it takes about 10 seconds to run this, and it uses about 76 megabytes in memory. If we use the same data in Polars, we see that it takes about 0.2 seconds using the same amount of memory. And this is quite interesting. If we compare the two execution times together, we see that Polars executes so much faster than Pandas, and that is why it's gaining so much popularity. So another difference between Pandas and Polars is that Pandas uses ego evaluation. So this means that when you perform calculations in Pandas, it happens immediately, whereas in Polars, we can use the lazy frame. We can use both ego evaluation and the lazy evaluation, but in the lazy evaluation, we use the lazy function, and this is one of the best things about Polars, is that it defers the calculation. So our calculation we're going to do here is that we can use the select function to select the column A and B, and then we're going to sum it and put it in a new column that's named sum. And then here there's no calculation being done at all. So when we use the collect function, that's only when the calculation gets called, and then Polars tries to optimize the query plan and distributes it across the multiple CPU cores due to its parallelization. And this makes Polars handle larger data better than compared to Pandas. And when we look at the output, this is the output. So this is using just the CPU. So we're going to move on to how we can use the GPUs on Polars. So Polars can use Nvidia's GPUs for high performance through its GPU engine that is powered by Rapid's CUDF. So when you're running this notebook, you can change the runtime type and make sure it's on this T4 GPU option. So when you do that, we're going to well, firstly, this is designed to make processing of tens or even hundreds of gigabytes much more faster. And this engine is actually built in the Polars lazy API. So we're going to be using the lazy evaluation throughout the tutorial now. And in order to use this, we're going to install the NVIDIA System Management Interface. So this is just a management tool for NVIDIA GPUs. So that is going to show the details of our GPU. So it shows that we're using the T4 GPU that's at 61 degrees, and it's using about 15,000 megabytes of RAM. And here we're going to see a little bit of the information of the CPU that we're using. And to use the GPU, we're gonna install the Polars library using the Nvidia's PyPy repository. So once you've done that, we can import the data set. So I've used a data set that's about 3 gigabytes. And I couldn't I don't think Colab allows you to put that data in its file section. So I had to import it from my Google Drive. So you can use your data, you can upload your data on your Google Drive, and then you can import it using this code. And once you get this notification, you'll see a pop-up coming up to connect to your Google Drive. Once you've done that, you can you'll see a folder called Drive, and you open it, you go to My Drive, and you look at the desired folder that you saved your data in here, and you copy the paths here, and then once you've copied the paths, you can scan your CSV. So in Polars, you can scan the CSV rather than reading it. So with scanning, it scans the file to build a query plan without loading the data into memory right away. And we can see a little bit of what's in our data. These are the columns and the data type in those columns. So to show the first 5 or the first 5 rows of the data set, the data frame, we use the collect function because you are using the lazy evaluation, and we can see a little bit of what our data frame of a data set looks like. So we're using the synthetic fraud data set. So now here we're going to run our computation that we want to do. So we're going to select the amount column, and then we're going to sum all of that, the data in that amount column, and see. So we're running this on the CPU, and it takes about 4.7 seconds and a total of 6.4 seconds. And then to run it on the GPU, we're going to define our GPU engine. And thus in this code here, we specify our device to use the first GPU on our system. So if you go back up here, we just have one GPU as our first GPU, the only GPU that we're using at 0. So we set that to 0, and here we set it to true so that it will raise an error if Polars cannot run the task on the GPU. So when we run the same computation, same code here, down here, but using the GPU engine, by just inserting the engine name in the collect function, we can see it took 1.4 seconds and a total of 3.44 seconds. So it took about half the time to do this computation. So we can go further by doing a little bit more of exploration on the data. So here we can create a new data frame by calling our data frame here and original data frame, and then we can group it by the customer ID, and then we can do aggregation to collect all the amounts that's with that customer ID and sum it, and then we're going to sort it by using the amount values in descending order, and we're gonna output the first 5 rows of the data frame, as you can see here. So this is the CPU, and it took about 8.7 seconds, and then we run the same code using a GPU. You can see that it took about 2.69 seconds. So the GPU is running the code quite faster. So we can do the same operation here on SQL. So Polos has a SQL interference as well. So if you know about SQL, and you would understand why these are in capital letters. And so it's just the same operations done. And when you run this, we can see it takes about roughly the same time to execute. So that's one of the benefits of using Polos. You can use SQL as well. So now we can do some basic data cleaning. So let's go back and see what our data looks like, the timestamp. So we're gonna clean this data here in this column here. So we're going to look at the timestamp column, and we're going to use this function here, this string, this function here to convert the text in the timestamp column, because it is in the string form, and convert it into a datetime object using the specified format here. And we're going to put that data in a new column called past timestamp. And when we run this code and we see the first 5 rows of that data frame, we can see at the end it has the new column. And we can go further by extracting the month and year of that datetime object by calling the column and using this dt.month function and creating a new function, a new column using this alias function and naming it the month, and same with the year. And then we can drop the original timestamp and past timestamp columns. When you run that, we can see at the end that we have 2 new columns, month and year, and we don't have the timestamp column anymore. So we can go further by exploring our data a little bit more. So here we want to find out which customers have the largest single transaction. So we can use the group by function. So we're grouping the data frame by looking at the customer ID. Then we use an aggregation to look at the column amount and find the maximum amount that is related to the customer ID, and we put that in a new column called max amount, and then we sort out that the values in that max amount column in descending order, and we see the first 5 rows of the data frame, and we can see it took about 8 seconds on the CPU. And so this didn't do any alterations on the original data frame. It's just it didn't do any alterations. When you look at the GPU, it took about 2.67 seconds. If we want to investigate a specific customer, we can use the filter function by looking at the column of the customer ID and looking at the specific customer number, and we can use the select function to select the maximum amount of that was related to that customer ID, and we can run the code, and we see it took about 7.4 seconds, and we got this, and we run it on the GPU. It took about 2.4 seconds. So these are all complicated computations, And you can see that the GPU is doing really well with these complex operations. So we can look at some relationships with our data. So we can look at, is there any significant interaction between the card type and merchant type in determining the amount spent? So we can run this code on the CPU and GPU, and by defining a new data frame, we can see that the CPU took 10.9 seconds, GPU took 3.1 seconds, and then when we try to visualize this plot, the scatter plot, we can see the relationship. So this is the HV plot library. You can see it's very interactive, and you can zoom in, you can move it left to right, and it's quite better than using Matplotlib. And then we can have a view of our res data frame. We can see that it's grouped by the merchant type and the card type and the country, like here. And we took the mean amount that's for each country here, and we sorted it out according to the merchant type. And we can see the data frame, yeah. So this is the end of our tutorial. And thank you.
Thank you, Pashlene. That was great. It was very interesting to see how much an improvement Polars really is. It's quite shocking to see. So I'm sure it'll be a very useful tool to have for any data science, especially with very big data sets. I haven't seen any questions in the chat from the audience, but if you have any questions now, then you feel free to ask. But otherwise, I assume that it was okay. Yes, perfect. Yes, Lorraine, with the raised hand, you can unmute yourself and ask a question.
Hello, can you hear me?
Yes.
Yes.
Okay, thank you for this presentation. It's very nice. It was very interesting, and we are not aware of the new library coming out, so it was very interesting to see what's happening. And even this plot library, it's very nice. My question is about memory. Is it managed better, the memory that Panda as well? Or because you showed at the beginning, it's the same memory size for both Panda and Polar. So does it manage better the memory, or it's kind of the same than Panda?
It does manage the memory better because Polars, since it's a multi-threaded library, it spreads the operation across the multiple threads across the CPU cores, whereas Polars it's single-threaded, so it just uses that one thread for the operation. So that's why it's faster.
Okay, thank you. And otherwise, we can find all the function that we find in Panda, we can find them in Polar.
Yeah, on the Polars website here.
Okay. Cool, nice, very interesting. Thank you.
Thank you.
Okay, great. Thanks. Are there any more questions possibly from the audience? Otherwise, I think it was a very good explanation, and you've given us all the right resources that we could want. So thank you very much, Pashlene, for a great presentation. And I hope that everyone enjoyed it. If you would like to reach out to us again, it's easy enough to find us on the NITheCS website. And this will be posted on YouTube in case you missed a bit of the beginning. It'll be on YouTube within the next few days. And with that, thank you everyone for joining, and hope you have a good weekend.